So in the interest of time, I will be skipping the graphing code, but basically this first cell takes the data and converts it to a GeoPandas data frame so we can actually use it. It finds all of the unique intersection points and it creates a graph out of them that we will then use in the rest of our program. Those will be the places that we can place our cameras. Next, we need to place the hotspots. So basically, what we do is we have hotspot clusters. We have 8 of them. Those are to simulate high accident areas. And we basically find the center of the cluster randomly, and then we pick spots along streets within that cluster radius to add hotspots to. Again, to simulate the high accident areas. And then any remaining hotspots we add to just random streets. And that gets us our hotspot map. And then we convert the hotspots to a data frame for easy use. These helper functions are important. This gets the hotspots that are covered by a certain camera, and this creates a dictionary where you can give it an intersection point, and it'll tell you which nodes are covered as a set. And that's generated for both algorithms. Greedy is very simple. It starts by creating the hotspot cache, so any camera will immediately know the hotspots that it covers. And then we loop through every single intersection and determine whether placing a camera there will result in the highest possible coverage, additional coverage. So we basically just pick whatever place gives us the most additional coverage, and we just loop through that until all the cameras are placed. For simulated annealing, we have a scheduler, and we have a function that gets the weighted coverage of all the cameras. And this is our neighborhood operator. So basically what it does is it removes a random camera and then places the new camera at a random intersection that covers at least one hotspot. Here you can see we actually filter out the cache for any items that don't have any coverage. And then the rest of this is very basic simulated annealing. And finally, we have this section of code which loops through a bunch of different possible parameters for method, alpha, and starting temperature to pick the one that is best, and we ended up with an alpha of about 1.5 and a starting temp of 1,000 with linear method as our best. So there were several interesting findings from this. For one, Greedy actually performed surprisingly well. In most cases, it was able to match or exceed the coverage of the simulated annealing, and often would do so in less than half the time, especially for some of these higher camera radius values. But interestingly enough, there were certain combinations of cameras and camera radius that we observed simulated annealing performing marginally better on. It would be interesting to investigate when specifically this happens, because it really doesn't seem to happen that often. I would imagine it happens whenever the camera radius is high and the camera count is low, or vice versa. If the camera radius is really low but there are a lot of cameras. I think in either of those situations, we might see simulated annealing performing better. So the other interesting thing is that among all of the parameter combinations we tried for simulated annealing, linear with alpha of about 1.5 always seemed to come out on top with about a starting temperature of 1,000, which is very interesting for a few reasons. One, it doesn't actually finish, like it doesn't hit the temperature limit. That's not why it exits. It always hits the max iterations first. That was also a common theme with the logarithmic, but logarithmic did not perform as well. And this is interesting because it seems to suggest that the exploration phase is very, very important for this problem, much more than the local search is at the end.
The most difficult and rewarding part of our problem was finding the data. Initially, I wanted to use a library called OSMX, which stands for OpenStreetMaps. It was really complicated. The syntax was hard. Downloading the data, it wasn't really working for me, and I kind of hit a wall. And then eventually, I pivoted to this data set provided by ArcGIS, um, which is local data from Louisville. It has each street mapped in a save file. So I was able to take this data and formulate in my code where I would add edges and vertices and nodes for the streets and the intersections because we had a goal of placing accident spots and cameras on intersections. And I was able to formulate that data and use it. And the final product was really, really cool to see. You can see it right over here. This is all just this map over here. I guess it's all these. It's all just from lines and numbers from a sheet of data.